Algebra 1, Lesson 10, Adding and Subtracting Real Numbers. This is the notes, this is the writing that this lesson gives you out of the book. When solving a problem containing addition and subtraction of signed numbers, begin by writing the problems as addition only. Next, group and add the terms with like signs. Then add the terms with unlike signs. And there's not a whole lot of description there. That's essentially all that they're giving you. All right, so what we're going to do for the rest of our time, let's see what you guys are out of here at, what, 48? 48. So for about the next 14, 15 minutes, we're just going to work out problems. Okay, that's it. Okay. So as I pull open some stuff, here we go. Let me kind of scoot things over so we got some good working space here. All right, question number 1, you guys that should be one of the easiest questions you're going to get, right? Because we have two fractions that we're trying to add together. If we're trying to add or subtract fractions, what do I have to have? Common denominator. Do I have that? All right, and once I have the common denominator, do I change the denominator at all? No, I don't change anything there, but I do what with the numerators? I add them. So what's 3 plus 5? 8. Boom. Done. Hoorah. They did most of my work for me. All I had to do is add 3 and 5. So no problems there, correct? Okay. Somebody's back there. Wait, hold on, slow down. You lost me. No, I hope not. All right. Same situation with subtraction. Do I have a common denominator? Okay, now I just have to work with 2 minus 6. Now, as we talked about earlier on, when we are subtracting numbers or even really adding numbers with different signs, we take the number with the highest absolute value, subtract the number that has the smaller absolute value, and then give it the sign of whatever has the greater absolute value, right? Yes? Which one of those numbers has the greater absolute value, 2 or 6? 6. So then I'm going to do 6 minus 2, right? 6 minus 2 is 4. What's the sign of the greater absolute value? Negative. So I should get negative 4 over what? Negative 4 over 7. Okay, so you get this right here. So if you go back and you watch the video, you notice that I didn't write anything down there. So you'd have to actually go back and listen to what's going on. Okay. This next part is where they really don't give you a whole lot of information, so I'm just going to have to give you what I would give you here. When we're talking about ordering numbers from least to greatest, there's a couple of things to keep in mind. Okay, for one, for ease of mentality, because we're dealing here with decimals and fractions, is that I would get everything in the same form. Okay, so I would go ahead and I would figure out what is 3/5 as a decimal. 0.6. So, just so we know, this is 0.6. Now, this question is easy enough that I may not necessarily need that, but it's good practice. The other thing that you need to know is when we're talking about negative numbers and it comes to the number with the least value, is that imagine a number line where, okay, we've got 1, we've got 2, we've got 3. Over here we have -1, -2, -3. So these numbers are least to greatest from left to right, correct? Which means the greater the negative number in what we're used to imagining, the smaller it is. -4 is smaller than -3. Do we get that? So even though the number appears to be bigger, that negative sign actually means that it's smaller. We get that, we understand that, right? Okay, good. Because when we're looking up here at this, what's bigger, -0.894 or -0.95? Which one is bigger? 0.895 or 894, right? Because it's not as big of a negative number. All right, so when it comes to negatives, the smaller the number, the bigger it is. Is that confusing? All right, we got it, hopefully. All right, so here, because 3/5 is the only positive number, really all I have to do is order my negative numbers, and I know 3/5 is going to be on the larger end, right? So in terms of least to greatest, I should get this right here, correct? Did I get that wrong? No? I'm good? Great. All right, let's see what kind of a problem. Okay, here, what do I want to do before I start into this? Put 4/5 as a decimal, which I think 4/5 would be the same as 8/10. So 8/10 could be written as 0.8, right? So some of these things I can do without a calculator. They work out really nice. So we've got 0.89, 0.7, and 0.8. Well, which is bigger, 0.8 or 0.89? 0.89 is bigger because what is after 0.8? What's after the 8? 0, and 9 is bigger. Okay, so if we order these from least to greatest, I should get 0.7, 4/5, and 0.89. Okay, so far pretty easy. Okay, let's come down here. They give me a chart. The distances students ran in a race are shown in the table. List the distances in order from, notice this, and this is where reading the question is important. Even though the last several questions have been least to greatest, this one is greatest to least. Okay? Between which two students' distances should Maria's distance be in this list? Okay, so we want to order these, right? Greatest to least. So what do I want to do with the fractions? Decimals, right? What is 8/9? 0.88. Okay. And 1/16. 0.0625. Okay. Now, I'm not telling you that you can't, because you could have, like with Patrick up there, you could have made that 2/5 and made that into 1/5, right? Then you would have had 8/9. Lou, you could have made 7/10. Stephen, you could have left as 1/16. Maria, you could have made 6/10, which would have been 3/5, correct? All right, you could have done all that, but you wouldn't have really still known what was least to greatest or greatest to least until you got a common denominator between all of them, right? So to me, maybe I'm telling you wrong or teaching you wrong. I hope I'm not, but I still view the decimal as a better indicator, a quicker indicator of size than fraction, because I've got to get all my fractions to common denominators before I can compare them. Okay? So looking through here, which of these has the greater value? What's first on our list? Jacqueline? All right, so 0.8, well, let's go ahead and leave them the way that they've got them, which is 8/9 is the greatest, right? What's next? Stephen? You're sure? You told me it was 0.0625, so I'm going on. Who is it, Lou? So 0.7, right? Okay, who's next? Maria. Okay, who's next? Oh gosh, let me, I go from numbers to names. 0.6, okay, and then 0.2, and then 1/16, right? All right, so I should get something like that. Maria is here, so she is between Lou and Patrick, okay? Let's see, we got 8/9, 0.7, 0.6, 0.2, 1/16. Maria's distance is between Lou and Patrick's. We get this so far. Yep, great. Okay, just as a quick refresher, you guys do know that I sent you your review for your first test, right? You guys have had that? All right, we know that we've got it. Has anybody looked at it? No? When is review day for our test? Thursday, next Thursday, right? And then you've got a test. All right, are you going to be ready for it? I hope so. Because I think they're taking theirs today, aren't they? Well, they've just, yeah, so it's fine. Here's the thing that's going to end up happening. Let me pause the video so that there's not a whole bunch of this in there if you try to go back and watch something. All right, so looking through here at the rest of these, are there any questions you feel like you want to go ahead and cover before we close? Because several of these are kind of repeats of the same type of question, order from least to greatest, greatest to least. All right, this one, number 11, has you graph them on a number line. Do you guys think you can do number 11? Okay, you guys can plot numbers on a number line. Again, I would still turn everything, either get it all into a fractional form with a common denominator or convert everything over to decimals. Okay? So I don't think that there's a lot more for me to tell you because it's basically just that. All right, we'll stop there and give you guys time to work.